record. Okay, so graphing. Question 8, we are converting from standard form to slope-intercept form. So the first thing we do in any question like this, we have to rearrange it into slope y-intercept form. A reminder, slope y-intercept form looks like this. Y equals mx plus b, which is to say you're getting y all by itself. That's the exercise here. We'll start. We subtract x from both sides, which turns our equation into 2y equals minus x plus 8. When you're working with lines, if you can get into the habit, when you move your x to the other side, of making sure that it goes into that first position after the equal sign with its sign, positive or negative, it just starts to immediately put it into the order we're going to want it in the end. Now that we've done that, we'll divide by 2 on both sides to get y on its own. So when we do that, that happens, and that happens, and that happens. And when we clean it up, it ends up looking like this. So we see this negative x divided by 2. The easiest thing to do with that, because you can't actually divide your x by 2, is turn that divided by 2 into a 1/2 and assign the sign to it. And that lets you know now what your slope is, because we can read it right off the question. We can see that our slope is going to be 1/2, and then at the end here, our y-intercept is going to be 4, so we're going to be using the point 0.04. These are the two things you're being asked to use to graph this question, which is why I pulled them out like that. And then doing just a really quick graph to see what that looks like. 1, 2, 3, 4. There's the point 0.04 right up there. Let me do that in a different color so it's a little clearer. There's our point 0.04. Our slope says negative 1/2. That negative says we're going to go down instead of up, so we go down 1 and over 2. Bing, bing. There's our next point, which is down 1 from 4, which makes it 3, and it's over 2, so it's the point 2, 3. Then we just draw a line through that. And that's as accurate as I need the graph. You can show me the 2 points, 0.4, 2, 3. Show me that you've identified your slope and your y-intercept, and everything's good. Jenna, my apologies. Let me make that available to you right now. I thought I had done that. Apparently not. 1 second. Okay, Jenna, it should be good for you now. Sorry for that interruption. Okay, so that's graph number 1. Just before I go on, because this is basically going to be the pattern, are there any questions on that? Okay, moving on to 8b then. Same pattern, same exact pattern, just different numbers. Negative 3x plus y equals 3. So again, we're going to rearrange it into y equals mx plus b form. This is much easier. I have no coefficients in front of y. So all I have to do is move that x to the other side of the equal sign. We add 3x to both sides, and it looks like this. positive 3x now, plus 3. So immediately we can stop and we can identify our slope, which is this 3 in front of the x. And just for clarity, I'm going to write it as 3 over 1. Then our y-intercept is 3, which means we'll be using the point 0, 3. Drawing out a quick graph. I want the point 0, 3, 1, 2, 3, there it is. I label it as 0, 3. My slope says 3, 1, which means I'm going up 3 and over 1. So go 1, 2, 3, approximately there, over 1. I'm going to be about there. Sorry, we'll do that in the right color. Be right there. Because we've gone up 3 from our point and then over 1, we're at the point 1, 6. We connect our dots in a very, very straight line like that. And that's all there is to it. Oh, certainly. So, and I'll do it with this one because I've done the same thing here. So our slope is 3 over 1. And our point is 0, 3. Now, I know this looks a little bit redundant here, but I'm going to remind you that that's an x-coordinate and that's a y-coordinate. This is your change in y. That little triangle is the Greek letter delta, and it just means the change in over the change in x. So because these are both positive, essentially what you can do is you can then just replace these coordinates with this delta y, delta x, okay, and add things. So what we're going to end up with here is the 3 plus 3, and then we end up with our 1 plus 0, which is how I ended up with 6 for my y-coordinate and 1 for my x-coordinate. Okay, James, you ready for the polynomials function test? Let me just assign that to you and assign you to the room, and then I will answer all of these questions that have popped up. Okay, James, you should be good to go. If it is negative, y doesn't go 2 to the right as the x goes down 1? That's a good question. And it's important to note that it is because of the negative. Now, if you decided that you wanted to go 2 to the right, then you wouldn't go down 1, you would go up 1. To make that super clear, I'm going to get rid of all of these. I'm going to do something just a little bit different so that we can just see what's going on with this slope. Let's say I've got a graph, and I've got a line, and I'm just going to try and make this a specific line because I want to work with, let's see here. Let's say that I've got a line, and in slope y-intercept form, I'm going to call this y equals 2/3 x plus 2. Okay, so I'm going to start at the point 0, 2, and I'm going to go up 2 and over 3. At the same time, I'm going to do another line that is negative 2 over 3 plus 2. So we're going to have the same starting point, but we're going to go differently with the slope, okay, just so that it all looks clear and easy. There we go. There's my quick little graph. So with the first one, y equals 2/3 x plus 2. This means that my y-intercept is at the point here, 0, 2. going by the slope, this means I go up 2 and to the right 3. They're both positive, so positive says up, positive says right. So I go up 2, 1, 2, and then over 3, 1, 2, 3. I add 2 to my y, I add 3 to my x, and now I'm at the point 3, 4. No problem. Then we draw a line, and it looks like that. If I'm going with the negative 2 over 3, again, we start at the same point right here at 0, 2. But now with the negative, I either go down 2, 1, 2, and then over 3, 1, 2, 3 to get me to that point, which in this case will be the point, make sure I get this right, 3, 0. Okay, so I've added 3 to my x value and subtracted 2, so I put the negative on the 2. If I decided the negative was going to go on the 3, then I would go to the right 3, but I would go up 2. So I would go up 2, 1, 2, and then backwards 3, 1, 2, 3. And you can see that when I do that, I'm still creating a line that's now going down to the right, okay? So that's another way that you can think of all of this. When you see this negative here, this means that you're going down to the right. Okay. When it's positive, that means you're going up to the right. I can go down and to the left, sure, with a positive slope. Okay, here's where I'm going down and to the left. So with a positive slope, if I go down 2, 1, 2, and backwards 3, 1, 2, 3, I'll end up right where I want to be. So in that sense, it's sort of like having a negative on both terms. Because a negative over a negative cancels each other out and they become a positive. Well, in a sense, there's two answers, except that because you end up lining up on the exact same line, it's really the same answer. The only coordinate you're really needing, yes, is that y-intercept. And then, yes, if you go down and to the left or up and to the right, you'll get the same thing if it's a positive slope. And the reverse, of course, if it's a negative slope. These are just lines I made up. Does it look like 8C? I think that's just coincidence. Let me take a look. Oh, yes, it's going to look very similar to 8C. That's just coincidence. Obviously, I like that this line. I must use it quite a bit. Let's go ahead and take a look at question 8C with all of this in mind and see if it all makes just a little bit more sense. We are going to come up with one of these lines. So we'll actually get to see how we got there from the standard form. Uh, 8C, which gives us in standard form 2x minus 3y equals 6. The 2x comes to the other side. We leave the negative 3y. Be careful when you're making this move in from standard form to slope y-intercept form. If there's a negative in front of the y coefficient, it's still there after you've moved the x. Otherwise, you're going to end up with the slope in the wrong direction, because now when we divide by -3 on both sides, and I'll do this to be clear, we're dividing by negatives all over the place. So everything now has to change signs. So the y becomes positive. My -2x over -3 becomes a positive 2/3 over x. And my -3 dividing this 6 turns this into a -2. So it's not quite exactly like my example questions, because now we're going to be at the point 0, -2. Okay, throwing this onto the graph really quickly. Boom, boom. We're down here at -2, bing, bing. There's my point, 0, -2. My slope is 2/3, so I'm going to go up 2, 1, 2, and over 3, 1, 2, 3. So I'm at the point here. We've added 3 to x, we've added 2 to y, so we're at the point 3, 0. Happens to be our x-intercept. That's kind of cool. However, if you decided to go the other way, as we've just been discussing, we could have gone down to bing, bing, and then backwards 3, 1, 2, 3. So if we had subtracted these points instead of adding them, then we would be at the point, let's make sure I get this right, -3, -4. All on the same line though, so you're good. Is this working for everybody? Cool, cool, cool. Okay, let's keep going. There's just one more to do for 8, so let's do 8D. Let's take a look at how this plays out. Okay, they're telling us 3x minus y equals 2. We move sides. I end up with -y equals -3x plus 2. To make that y positive, I need to divide by -1 everywhere. And when I do that, I have y equals 3x minus 2. So my slope is going to be 3 over 1. My y-intercept is at -2, which is at the point 0, -2. So this graph is going to look very similar to the one that we just had, just a little bit flatter. So we're down here at -2. There's my point, 0, -2. My slope says go up 3, 1, 2, 3, and over 1. So we're there, and we're at the point 1, 3. I could go the other way, go down 3, 1, 2, 3, and over 1, and then I would be at the point -1, -6. Sorry, I said flatter. I should have said steeper. We have a slightly steeper line. There we go. Could I not move the y over the equal sign then? Yes, you could do that. You could move the y and move the 2. Works the same way. As long as you get y on its own on one side and you watch the changing of your signs, whichever way you do it works out just fine. Oh, when I'm saying we could minus instead of adding. So that's just referring to what's happening with the slope and the y-intercept to make these points. So again, with 3 and 1 representing our y and our x values, sorry, let's try that again. We've got -2 for y and 0 for x. Those are our starting points. And then I can add 3 and I can add 1, which gets us to the point what have I done here? That's y. I said 1, 3. It should be the point 1, 1. That's much better. So when we add these, -2 plus 3 gets me 1, 0 plus 1 gets me 1. So this tells me that I'm at the point 1, 1. I can go the other way, though, doing the exact same thing. Still starting at -2 and 0. I could subtract 3 and subtract 1. So instead of going up, I'm going to go down. And this gets me to the point -5, -1. In the right order, though. -1, -5, which is this point here. So it's just a question, are you going to go up and to the right or down and to the left if it's a positive slope? It's really just a matter of which way makes sense in your mind. Culturally, because we tend to read left to right, I tend to think of going always up to the right, but it's not necessary. You could go the other way. Okay, any other questions with regards to graphing before I move on to solving equations? Okay, so let's start with some solving equations. I had a request to go over infinite solutions and no solutions. So I'm going to start by doing that before actually, sorry, infinite solutions versus no real solutions. So we're going to take a look at that before I start working any of the specific problems. Let's start off with the idea of infinite solutions. Just because sometimes that once we get that idea, we can see why we would then have no solution. So with infinite solutions, always what you've ended up with is the same line somehow. Just rewritten. For example, if I had the line, let's go with something that I don't use terrifically often, I don't think. Let's go with 4x minus 3y equals 2. And then if I had the line 12x minus 9y equals 6. One of the things we want to immediately notice about these lines is if I took this first line and I simply multiplied it by 3, it would give me this line. So really they're just the same line, just scaled, okay, just multiplied by 3, so that it looks like it's something bigger than the first line. But because these are the exact same lines, I can pick any x and y numbers I want. Oh, sorry, you're taking test 3? Ah, that's the issue, Jenna. I don't have test 3s available until next week because I want everybody to be doing their first pass through all of the unit tests before they go back and take a repeated test. So I'll have test 3 available on Tuesday. You're going to write test 4. Okay, hold on a sec. Let me assign you. And you should have access to it right away, so you can go ahead and start. Okay. So if I pick any coordinate for x and y, and let me pick the point 1, 2, just for example, and I put these coordinates in, 1, 2, into this equation. So I'm going to get 4 times 1 minus 3 times 2, and that should equal 2 if we do this right. Well, 4 times 1 is 4 minus 3 times 2, which is 6, equal to 2. Well, that's not right. So apparently that needs to equal negative 2. Apparently I just did that wrong. But if I put in a negative 6 here, that'll work it out. The same exact thing should happen if I stick my 1 and 2 in the 12 and 9. 12 times 1 minus 9 times 2 should equal negative 6. 12 times 1 is 12. 9 times 2 is 18. And indeed, it does equal negative 6. So we can see that these points end up creating the exact same line both ways. So that's why we end up with infinite solutions, because you can just pick any pair of numbers that you want and it will always work. Let me give you a visual idea of that. If we take some pair of lines, it doesn't much matter what the line is, but there it is. And I had another line and it lay right on top of it, like that. Then any pair of points that I pick are going to be valid for both lines. And that's why we end up with infinite solutions, because I can pick any point anywhere along the line, and this line goes on forever, so my option for points goes on forever, which is why we end up with infinite solutions. Working the same idea for no real solutions. I'm trying to just squeeze this in here because I want to try and do it on the same line. No real solutions just means we have a parallel line. And again, just looking at it visually, if I take a line and I go like that, and we can see that they are parallel lines, it doesn't matter which pair of points I pick. No matter how far I go infinitely in both directions, these lines are never going to cross. Because the lines are never going to cross, we're never going to get a solution, because when we use the word solution, we literally mean where do the lines cross. So if your lines never cross, you can have no real solutions. If your lines are always crossing, you have an infinite number of solutions. If your lines never cross, you have no solutions. So those are the two special cases. Let's go through a couple of problems and see how this applies. Okay, so we were looking at solving equations homework. We're going to start off, we're going to do question 3A, then we'll do 3E, and then we will do 3H. So 3A. This is asking us to use the quadratic equation. X squared plus 3x plus 3 equals 0. We're to use the quadratic equation to come up with solutions. A reminder of what our quadratic equation looks like. X is going to be equal to negative b plus or minus square root of b squared minus 4ac all divided by 2a. I know I've got that tucked up in the corner. That glare is just a bit much. That won't work. Okay. So first thing we want to do is identify our A, B, and C from this equation. So A in this case will be equal to 1. It's the number in front of x squared. B is going to be equal to 3. It's the number in front of x. And C will also equal 3. It's the number all on its own. Taking these, and we will put them into our quadratic equation. So negative b becomes negative 3 plus or minus the square root of 3 squared minus 4 times 1 times 3, all divided by 2 times 1. When working with the quadratic equation, it's always easiest to start off with the part under your radical. This is called your discriminant, because we can immediately see if we need to go any further. So when I do this, my negative 3 plus or minus comes for the ride. It's all still under the root sign. And I end up with 9 minus 12. Well, I don't actually have to go any further at this point. Sorry, 2 times 1 is just 2, not 21. 9 minus 12, I know that 9 minus 12 is going to be a negative number. Okay? So what this is going to get me, in fact, is negative 3. So we want plus or minus the square root of negative 3 all over 2. Because we're trying to take the square root of a negative number, there are no real solutions. We cannot take the square root of a negative number. Question 3E. This is one, I was asked to do this one. The answer key is wrong on this one, which is part of the problem that's going to be throwing people off. The answer key says negative 10, and it is not negative 10. So let's take a look at what it will be. This is 3E. Which says x squared plus 10x plus 25 equal to 0, which means my A is 1, my B is 10, and my C is 25. We're going to put this into the quadratic equation. So negative 10 plus or minus the square root of 10 squared minus 4 times 1 times 25, all divided by 2 times 1. We simplify all of this, so I'll get negative 10 plus or minus 100 minus 100. And that's important for us to note. 100 minus 100 is just going to go to 0, so we're only going to end up with one answer out of this. And end up with negative 10 divided by 2, which should get me negative 5, which is the answer I'm actually looking for. Okay, and then we will do what did I say? 3H. As our last one. I must have meant F. Yes, I did. So 3F. Which says x squared plus 6 equals 2x. First thing we want to do, let's rearrange this. Let's get everything over to the other side. So I'm going to end up with x squared minus 2x plus 6 equals 0. Now my a is 1, my b is negative 2, and my c is 6. I'll put all of this into our quadratic equation. Negative b means positive 2 plus or minus negative 2 squared minus 4 times 1 times 6, all divided by 2 times 1. We clean it up. 2 plus or minus square root of 4 minus 24, so it's going to happen again. We're going to end up with a negative. I end up with negative 20, which we don't want, so no real solutions. Any questions on those before I move on to question 5? Okay. The request I had was for 5H. If there are any other requests for me to go over questions in question 5, throw them up into the chat real quick while I go through 5H. So this is a systems of equations question. This is asking us to solve by substitution. And the equations are 2x plus 2y equals 2. And the other one is 3x minus y equals 1. Because we're looking for substitution, we're looking to get one variable on its own. This is the easiest one in my mind to get on its own, so I'm going to rearrange this equation, and I get negative y equals negative 3x plus 1. I will divide by negative 1 everywhere, and I end up with y is equal to 3x minus 1. This is now what I'm going to substitute back into my first equation. So I end up with, I don't need the quadratic equation here anymore. Let's get that out of the way. So I'll end up with 2x plus 2 times 3x minus 1 equals 2. We'll expand. 2 times 3x is 6. 2 times negative 1 is negative 2. So 2x plus 6x equals 8x. I add 2 to both sides to get 4. I divide by 8 on both sides and clean that up, and my x is equal to 1/2. I can now put this x equals 1/2 back into this equation. So y is going to be equal to 3 times 1/2 minus 1, which is 3/2 minus, I'm going to turn my 1 into a 2 over 2 right away just to make my life easier. So 3/2 minus 2/2 equals 1/2. So my y equals 1/2. My x equals 1/2, so my final answer is going to be the coordinate pair 1/2, 1/2. Sure. By that last bit, you mean from solving from x? Okay, so basically what happens is we found a solution for x. Now x can go back into the equation we created. And when we do that, it ends up looking like that. So 3x minus 1, my x is equal to 1/2, so I have 3 times 1/2 minus 1. 3 times 1/2 is 3/2. Negative 1 with 2 as the denominator becomes negative 2 over 2. I set that up so I can do my subtraction. 3/2 minus 2/2 is 1/2. And then, yeah, because I have a y value and an x value, I have a final solution. Any other questions on this? Okay, so just a reminder, I am recording these. I will get them posted first thing in the morning, if not last thing tonight. So people who are trying to go over this over the weekend will have these questions to refer to. Moving on to the word problems. I was asked to do the word problems, all of them. So I'm going to go to question 7, which is probably good. The hardest part about these word problems is seeing how we take these words and translate them into the math. Once we have the equations set up, the math itself is not terribly hard. But the hard part is getting things set up. And we're taking a look at what we're going to do with percentages in this case. So, Shannon's Catering is planning a spread for an open house. She's planning to serve a locally roasted mix of nuts. She would like the nut mixture to be 25% peanuts. So we want 25% peanuts. But the only sources of mixed nuts she has come as either 40% peanuts. Did I spell that right? No, I did not. Ha. Try that again. 40% peanuts or 10% peanuts. How much of each mixture would she have to combine to produce a 10 kilogram patch of nuts containing 25% peanuts? So 25% peanuts in 10 kilograms. That's our goal. And we have 40% peanuts and we have 10% peanuts. So how do you go about setting all of this up given all of that information? Here's how it goes. I have 2 types of peanuts. I'm going to call my 40% peanuts X. I'm going to call my 10% peanuts Y. And here's what I know about X and Y. I know that however I combine these, when I combine them, I'm going to have 10 kilograms in total. So that means that X plus Y is going to be equal to my 10 kilograms. The other thing that I know about this is that in my first mixture I have 40% peanuts. 40% as a decimal is 0.4. That's from some of our earlier lessons. So 40% peanuts would look like that. 40% of whatever weight of X we get is going to be the peanuts. Similarly, 10% of the other mixture, so 0.1 Y, will be peanuts. 10% peanuts in the other mixture. So when we combine this, we should end up with the 25% peanuts in our 10 kilograms. Well, 25% peanuts in 10 kilograms is going to be 0.25 times 10. This is the really tricky part sometimes to visualize, but it makes sense when we think about what this is describing. The peanuts from my first bag, my 40% peanuts, and the peanuts from the second bag, my 10% peanuts, when they're put together, should only equal the peanuts in my 10 kilograms that I'm looking for. Now that we've set this up, I'm going to clean up this first equation. I'm going to leave equation number 1 like that for a minute. Equation number 2 I'm going to rewrite. So equation number 1 is still X plus Y equals 10. equation number 2, when I clean it up, becomes 0.4x plus 0.1y equals, well, 0.25 times 10 is 2.5. I can take equation number 1, I can rewrite it so that we can do this by substitution, which is the easiest way to go. So what I'm just going to do is I'm going to just immediately take this, I'm going to say this is going to be 10 minus x. I've just moved the x to the other side. So now I can take what y is equal to and I can put it into the second equation in place of y. And so now when I rewrite my second equation, I will get 0.4x plus 0.1 times 10 minus x equals 2.5. Don't know that I've left myself quite enough room to squeeze this in, but I'm going to give it a quick shot. When we start to rearrange this and clean it up, I have 0.4x. 0.1 times 10 is 1. 0.1 times negative x is minus 0.1x, and it's still equal to 2.5. I'm going to do a bunch of cleaning up all in one motion. I will color code it so you can see what's happening though. Those are going to go together, no problem. My 1 is going to come over to the other side and subtract. And when we do that, 0.4x minus 0.1x is 0.3x. Subtract 1 from 2.5, and I end up with 1.5. Then we'll divide by 0.3 on both sides. Sorry, I got distracted for a moment. 0.3 cancels. 0.5 divided by, or sorry, 1.5 divided by 0.3. Plug that into a calculator. I'm going to put this all over here. Gets us x equals 5. This is really nice because we have this equation, x plus y equals 10. So if x is equal to 5, y must be equal to 5. So our solution ends up being 5. 5, another way to put it is I need 5 kilograms of 40% peanuts and 5 kilograms of 10% peanuts. And that will give me a 25% peanut mixture in 10 kilograms. So yes, then we put it back into equation 1. So I took that, there's my equation 1, just rewritten with 5 instead of x. And we can clearly see that y is equal to 5. This part right here, putting together the equation, the second equation, when you're dealing with percentages, this is pretty much your pattern every time. You're going to get two things that add up to something just on their own, some x plus y equals something. And then with your percentages, percentage of your first part plus the percentage of your second part should equal the percentage of your total. I believe we have another percentage question coming up that we can take a look at that. Yes, we do. In fact, we're going to do it exactly again with the next question. So I'm going to just write out what I just said so that it's clear for everybody. When we're trying to solve these equations, things that you need to do. Identify your two things and the total. Okay, your two things are your x and your y, and your total is what they're equal to. Okay. If you're dealing with percent, then percent of x plus percent of y is going to be equal to percent of total. Okay, where your percent is actually going to be as a decimal. Then solve by any method. So that's the pattern that we're going to follow. We're going to identify our things and their total, which is going to give you your x plus y equals something. Then we'll get a percentage of x and a percentage of y to equal a percentage of our total, where our percents are done as a decimal. Then we'll solve. Let's take a look at that with question 7b. So, question 7b says, industrial cleaning supply sells 2 whiteboard cleaning products. This is very, very important. One of them is 25% hand cleaner. So we have a, oops, let's try that again. So we have 25% hand cleaner. And then the other one is 50% hand cleaner. How much of each would be needed to be combined to make a 15-liter solution that is 40% hand cleaner? So that's what we're trying to put together. Thank you, Jenna. Let me just take a quick peek. I'll give everybody a chance to make their guess as to how this is set up while I just take a peek here. Okay, Jenna, I have it. Thank you. So, going with this, we'll identify that as x, and we'll identify that as y, and we'll identify that as our total. I'm going to try and leave myself enough space, so I'm going to try and do this in 2 halves. From this, I can identify that I want x plus y to equal 15, because I want a total of 15 liters. This also tells me that I'm going to want 25% of x and 50% of y to get me 40% of our 15 liters. Cleaning this up, I end up with 0.25x plus 0.5y is going to be equal to simply 6. I can immediately jump to the fact that I can replace my y with x minus 15. And when I do that, I put this in here for y, and I'm going to end up with the equation 0.25x plus 0.5 times x minus 15 equals 6. We keep doing this. I get 0.25x. Oops, that's backwards. Let's try that properly, or I'm going to get the wrong things. 15 minus x, that's better. 0.5 of 15 is 7.5 minus 0.5. X equals 6. Same thing's going to happen as happened last time. Those go together, and this goes to the other side. When that happens, I end up with negative 0.25x, and that's going to be equal to negative 1.5. We'll divide by negative 0.25 on both sides. Uh, 1 second, Beth, and 1 second, Allison. And so then we end up with interestingly enough, we end up right back where we started with 6. We take our 6, we put it back into our original equation. Okay, so if 6 plus y equals 15, then we can immediately know that y is going to be equal to 9. And that is our solution. Okay, Beth, I thought I had made that available to you. Let me just double check what's going on here really quickly. You're trying to access the trigonometry exponents version 2. Is that correct, Bethany? It should be available to you. And you're trying to access version 2 in week of 17th, August 17th to 23rd? Yes, you should be looking at the trig test from the week of August 17th to the 23rd. That's very strange. It should be available to you. Okay, Bethany, I'm going to email it to you right now. Okay, Beth, I've emailed that to you. I'm going to assign you to the breakout room. As soon as you have it, you can go ahead. Allison, thank you for your patience. Let me just double check. Good, I've got it. Thank you. Well, thank you very much. I hope you do well in the future stuff. Bethany, great. You can pop into the breakout room and go ahead and get started. Oh, yes, I've seen that you submitted your homework, but that was my fault. I shouldn't have set it up as something to be submitted. That was just for your own work. I didn't have to mark that, but I have looked at it, so it's looking good. And Ryan, I see that I have yours too, so you're good to go. Okay, thank you for that brief divergence, everybody, as I took care of that. Are there any questions about this? I sort of scrambled through the end there as I got slightly distracted. Any questions on what we're doing with percentages and solving equations? We're going to do one more. That involves percentages. This is sadly something most of you will probably have to deal with at some point in your life. It's a student loans question. So, question 7C. Sarah's 2 student loans total a very modest $19,000. The first loan, which we'll call X, is being charged 7.5% simple interest. The second one is being charged 6% simple interest. At the end of the year, she has accumulated $1,338 in interest. Now, this question, what are the sizes for loans? So we need to figure out the size of X and Y. Now, this is a percentage question, and in our 2 previous percentage questions, we ended up having to put together and calculate out the percentage of our total. In this question, if you read it carefully, you'll discover that what they've done is they've actually already calculated the percentage of your total when they've given it to you as interest. Interest is always some percentage of a loan. They've given you the actual number, so they have calculated it out for you. So then, because of that, this is how these equations set up. We're still going to get our X plus Y equal to 19,000 because our 2 loans added together come to $19,000. The interest from our loans, 7.5%, so 0.075. Be careful and make sure that you keep that leading 0 or it doesn't work. Same thing with the 6, 0.06Y. When we calculate those out, they're going to give us $1,338 in interest. Same thing we've been doing with everything. I'm just going to move the X to the other side and put it in here. So I'm going to do this all in one step. 0.075X plus 0.06 times 19,000 minus X will equal 1,338. So this is where you want to pull out a calculator really quickly and calculate what is 6% of 19,000. 0.06 times 19 and 3 zeros. And we're being told that that number is going to be 1,140. So that's there, plus 1,140 minus 0.06x will equal 1,338. Same steps as always. These two things are going to come together. This is going to move over here and subtract. And when we do that, I am left with, let's make sure that this is still all going to be visible. Squeezing this in here, I'm going to just get rid of that line so I can squeeze it a little tighter here and end up with 0.015. X is going to be equal to oh, I got to do that quick bit of subtraction. 1338 minus 1140. 198. I should have been able to do that in my head. Oh well. Then we'll divide by 0.015 on both sides. And it tells us that X is going to be equal to 13,200. Because X is equal to 13,200 and Y is equal to 19,000 minus X, I can do a quick sidebar and just say that Y will then be equal to 5,800. So there we go. There's your two student loans, 13,200 and 5,800. And even though these days nobody is seeing loan percentages of this amount, that is how it would work out. Oh, okay. So, so two things really quickly. So, Beth, if you have the test up on your screen, you can write out your answers on paper and then take pictures of your answers and upload those. Okay, so this is what ends up happening. We have two student loans. So you've gone to the bank, you've taken out loans. In total, you've borrowed $19,000. Okay, so your loans are going to be X and Y, and you get $19,000 on them. When we calculate the interest, we're going to calculate the interest on the X loan at 7.5%, so 7.5% of however big X was, and then 6% of however big Y was. And at the end of the day, because we've just calculated the interest on both those pieces, when we add it together, we're just calculating the total interest. Okay, and so does that make a little bit more sense? So then when we rearrange this and then we reverse engineer it, it then reveals to us what our original X was, what the original gross amount of that loan was. And because we know the gross amount of that loan, we know the gross amount of the other loan. Sorry, yes, I can see how that would be confusing. I was just trying to keep track of the fact that our X loan goes with 7.5% interest and our Y loan goes with 6% interest, so that when we set it up, we have that there. It is a ratio, yes. Cool. Happy to see that. Any other questions on this before I clear it and we go on to something just slightly different? Okay. The last one, compared to these that we've just done, this last one is very, very simple. And again, something that you may end up doing in your real life on a regular basis now. Anyway, so Bill has gone to the bank. Ben has gone to the bank to get change for a $50 bill. And he just gets loonies and toonies. So he's got a whole pocket full of loonies and toonies, and he's got 35 coins. So how many of each coin did he get? So we have 35 coins of $1 and $2 sizes, totaling $50. Okay, so if I say that my loonies are going to be X and my toonies are going to be Y, now this is where we want to be careful. If I have X plus Y, my total is going to be 35 because it's the number of coins. I have a certain number of loonies and a certain number of toonies. And that certain number, when I add them up, gets me to 35 coins. But if I take the value of those coins, so if I want $1 for every X and then $2 for every Y, when I put those together, then I should come up with 50. In all of our previous questions, we've been doing this by substitution. I'm going to do this one by elimination, just for the variety of it. So what I'm going to do is I'm going to take this whole equation and I'm going to multiply it by 2 so that my y's are the same. And when I do that, I discover that if I have 2x plus 2y will equal 70, and then 1x plus 2y. This should be a y, there we go, equals 50. If I then subtract these two equations, 2x minus 1x just leaves me with x, 2y minus 2y leaves me with 0, and 50 minus 70 gets me to 20. And poof, just like that, my answer for x pops out. X equals 20. Put this back into my original equation of x plus y equals 35. So now I know that 20 plus y equals 35, so I know that y equals 15. And just like that, our answer pops out. We have 20 loonies and 15 toonies. Okay, and that's that. That's all of question 7. Any questions on those word problems? Okay, I'm going to pause the recording for a minute. If anybody has any other questions they'd like me to go over, just throw them into the chat right now. I'm just going to pop in and check on the test.